back with new PowerPoint presentation, and this time I am going to show you how slingshot experiment is done with DUI Drive. In this experiment I will fire something. Slingshot means using rubber. I will throw something, but you won't see any reaction of that throwing action. Okay, let's start with the presentation. Okay, I want to first watch this video for you for understanding. Let's play this one. Look how the bomb is getting fired. Did you see? The body moves forward. The cannonball fires. The cannonball in the projectile motion, and this body moves backward as a reaction. Action, the move, the cannonball moves forward, and reaction, the body cannon moves backward. As you already know, every action have equal but opposite reaction. Let's go to the another slide. When a cannonball is fired, did you notice cannon being pushed back? It's due to the reaction force in opposite direction generated by the action, cannonball being fired in that direction. Yes, that's action and reaction thing. Let's move to another slide. And now we want to make our own slingshot type of apparatus. And this is frame where this is pivoted wheel. There are 3 pivoted wheel. They are added here to have at least friction between this frame with the ground. And these are 2 bullets. For now these 2 are bullets because they are going to be fired forward with the help of rubber, but they are rotors. They rotate also. They are called rotors, but this time they will be used as bullets. And we need rubber too, and thread too, but they are not here, and thread cutter too, and they will be in the experiment, but I just forgot to mention here in the beginning, but you will see in the video, next video. Okay, let's move to the slide. Let's fire it. Okay, let's fire it. Here I have, this is the bullet, this is rotor. It's tied up in 2 places. Here the thread has been tied up, and these are the rubbers. The rubbers has tied is tied with the bullet in such a way that it is balanced by the thread. Otherwise, when this thread is released or cut, the rotors or the bullets will move forward. It's just held by the thread over here, balanced. Okay, let's play this video. It's in slow motion so that we can observe it very clearly. In fast motion we can't catch. Did you see that? The frame moves backward and the bullet or the rotors move forward. Like every action have equal but opposite reaction. The frame moves backward and the bullet moves backward. Let's see it once again. You can clearly see that when the thread is cut, both of them move away from each other. Yes, every action have equal but opposite reaction. Okay, let's move to the next video. And the same here, like the cannonball which moves forward, moving its cannon backward, and same here, the frame moves back and the bullet rotors is fired forward. Okay, let's move to the next slide. From these two videos, it's clear that every action there is always opposed and equal reaction. This is Newton's third law of motion, the most undisputed and laws of physics till date. This law has worked as foundation of physics, and all the modern machines and locomotives are operated under this law, and no anomaly against this law is discovered. This law has not stated directly, but given to an understanding that if you want to move forward, you should push something backward, or if you want to go up, you should push something down. Yes, we know. And there are other things. What goes round comes around. Something. There are a lot of saying that has given. It may not be derived from this equation, but there are many sayings related similar. Okay, let's move to the next. In contrary to this understanding, I observed action and reaction between at least two bodies that resulted in unidirectional motion of both the bodies in same direction, but not in opposite direction. So I had proposed a new theory which states reactionless unidirectional momentum, thrust or force could be generated within the two bodies in a desired direction by interacting those two bodies with each other in a specified way. And this new theory just says that you don't have to push anything backward, like the way you see in Newton's third law. When the cannonball moves forward, the body moves backward. And the second slingshot mechanism, when the bullet is fired forward, the frame moves backward. But this is not necessary for a body to move forward. Two bodies can react with each other in a specified way, and they can move forward. This is the main objective of this presentation. Okay, let's see how it works in the similar apparatus. Okay, let's see how it works in this video. This two body moves in this direction, and nothing, this two body doesn't pushes anything back, like the cannonball pushes its cannon back, and in the slingshot experiment the bullets pushes the frame back, and here also it's very similar apparatus. These two body rests in this frame, rotor 1, rotor 2, okay, bullet 1, bullet 2, and they are tied with this rubber band. This is the required action. Okay, let's move this, play this video first. Okay, when the thread is cut, and this frame has very less friction used pivot wheels. Let's see the body thread cut. When the thread is cut, these two bodies react with each other in such a way that they move forward. Let's see. I don't know what's going on with this internet connection. It's slow, but let's see it once again. Okay. The body moves forward, but this doesn't move backward. The bullets moves forward, but this frame doesn't move backward. Okay, let's play this once again. Okay, instead the friction between the friction between this bullet and this frame moves the body forward but doesn't move anything backward. Now it's enough to say what happened. Okay, You can clearly see there is no any reaction in the opposite direction to the movement of the bullets rotors. The last part of the video is played in 4 times less speed for clear view, and you already view it. This proves the proposed theory. Reactionless unidirectional momentum, thrust or force will be generated within two bodies in a desired direction by interacting those bodies with each other in a specified way, and no need to throw something backward for you to move forward, not pushward. Very bad English. My background is not English, but I'll try my best. Okay, thank you. Thanks for your time.